Alright, so in this video we go over section 11.4 matrix algebra. So in this case, so we have already defined what matrices are. We use them to solve systems of equations, both using the graphing calculator and by hand using Gauss-Jordan elimination. So now we're going to do operations with these matrices, which is add and subtract matrices, find scalar multiples of a matrix, and find the product of two matrices. Well, so consider the matrices A and B, in which they have the corresponding elements. They could be of the same size, or actually they have to be the same size in order for two matrices to be added or subtracted. And all we do is simply combine elements with the corresponding elements that are in the same position. For example, the element 1 1 gets added with the element B1 1. The element A1 2 gets added with the element B1 2. As and so on and so forth for all the matrices, for all the elements in the rest of the matrix. So let's just do one simple example to see how this works. Well, so in this case, A plus B, that's 5, 4, 9 minus 6, plus B, that's 3, 8, 6 minus 7. And all we do is simply add 5 plus 3, which equals to 8. And then 9 plus 6, which equals to 15. Four plus 8, which equals to 12. And careful with negative signs in this case. So what we do is negative 6 plus negative 7, that's negative 13. And that's all we do. As easy as add or subtract numbers. Scalar multiplication, well, so we have a constant C multiplying an n by n matrix. So all we do is multiply all the numbers that are inside the matrix by that constant. For example, in this case we have C equals to 5 and A equals 5, 4, 9, negative 6. So C, which equals to 5, and 5, 4, 9 minus 6. All we do is multiply. 5 times 5, 25. 5 times 9, 45. 5 times 4, 20. 5 times 6, negative 30. And that's all we have to do. All right? As easy as multiplying numbers. Now, the trickiest of this is when we multiply a matrix with another matrix. Well, but first let's define the identity matrix, because we're gonna need it later. And again, we have already defined the identity matrix when we solve systems of equations. We using Gauss-Jordan elimination of the calculator to set it into RREF. So we had ones along the main diagonal and zeros everywhere else. And we have this notation I sub n. For example, I sub 2 will be a 2 by 2 matrix in which the main diagonal is 1 and zeros everywhere else. And then, I don't know, maybe I4, that's going to be a 4 by 4 matrix in which we're going to have ones along the main diagonal and zeros everywhere else. Just like this. Alright, and so on and so forth. I5 would be a 5 by 5 matrix with ones along the main diagonal, zeros everywhere else. Alright, we're gonna get back to use this in the next page. First, let's go over matrix multiplication. So in this case, we are going to multiply the matrix A, which is m by r, that is it has n number of rows and r number of columns. And then we have another matrix B that is r by n. In other words, it has r number of rows and n number of columns. So the product will be AB, and in this case, in order for this product to be defined, the number of columns of the first matrix, that is R, has to be the same as the number of rows of the second column, and the product, the new matrix, will have the number of rows of the first matrix and the number of columns of the second matrix. For example, let's see, if we have a matrix that is A of 3 by 5, 3 rows and 5 columns, times a matrix B that is 5 rows times 5 rows by 6 columns. Well, these two numbers are the same. Okay, the number of columns of A is the same as the number of rows of B, and the product matrix AB will be a matrix that will have 3 rows and 6 columns. Let's do one example to see this in action. For example, A and B. Let's see number 1 if it is defined. Otherwise, if these two numbers are not the same, then the product is not defined. So let's see. Let's multiply A and B. By the way, in this case, order is going to matter. So -1, 4, 5, 3, -2, 0. Multiply that by -3, -4, 2, and 1. In this case, we have a 3 by 2, and this is a 2 by 2. 3 rows and 2 columns. 3 rows, 2 columns. And this one is a 2 by 2. 2 rows and 2 columns. And then in this case, well, notice these two numbers are the same. And our final answer will have 3 rows and 2 columns, just like matrix A. How are we going to multiply those matrices? Well, so I'm going to use pencil here. So let me prepare a blank 3 by 2 matrix. Okay, so we need to obtain the 1, 1 element. We get the 1, 1 element by multiplying the first row times the second column. In other words, -1 times -3. By the way, let me give some space here. I'm gonna do the whole thing. Okay, so what I'm gonna do is -1 times -3. That's +3. And then in this case, plus 3 times -4, that's actually -12. All right. So this 12 came from multiplying this 3 with this -4. And then let me erase this. And you can do what I'm going to do next is to find the 1, 2 element by multiplying this time. Well, maybe actually box it instead of just scratching. So I'm going to multiply the first row times the second column. So that's going to give us -1 times +2. That's a -2. And then 3 times 1. That's a +3. Okay. Let me erase these boxes. And now what we are going to do is to multiply the second row with each column to obtain number 1, the 2, 1 element and the 2, 2 element. So I'm going to multiply 4 times -3, which is -12, plus negative 2 times negative 4, that's going to be positive 8. And then, once we're done with that column, let me do the second column with the second row with the second column, the second row of the first matrix and the second column of the second matrix. So this is 4 times 2 plus negative 2 times 1. In other words, 4 times 2, which is 8, and then negative 2 times 1, that's a negative 2. Okay, let me erase these boxes. So, we are going to multiply the third row by first column of the second matrix. So I'm going to do 5 times negative 3, which is negative 15, and then plus 0 times negative 4, which is 0. Okay, let me erase this first box on the second matrix and let me box the second matrix. So we do 5 times 2, which is 10, and 0 times 1, which is 0. And all we do is add each component wise. 3 minus 12, that's a negative 9. Negative 12 plus 8, that's a negative 4. All right, is that what it is? Or 8 minus 12, that's a negative 4. Negative 15 plus 0, negative 15. And then the second column is going to be negative 2 plus 3, that's positive 1. 8 minus 2, which is 6. 10 plus 0, which is 10. And this is final answer. And notice this is a 3 row by 2 column, 3 by 2, as we expected. Let's see if the product works the other way around. That is negative 3, negative 4, 2, 1 times negative 1, 4, 5, 3, negative 2, and 0. In this case, well, we have a 2 by 2 matrix and a 3 by 2 matrix. Now, if we look at this, these two numbers are not the same. And for this reason, this product is undefined. This product is undefined. All right. So these two again have to match. Let's do a couple of combined practice examples. So we are given 3 matrices A, B, and C, a 2 by 3, a 2 by 3, and a 3 by 3. Let's actually list the dimensions of the matrix. That's 2 rows by 3 columns, 2 rows by 3 columns, and 3 rows by 3 columns. All right. So let's do the operation 3a minus 2b. Okay, 3a minus 2b, that is 3 times the first matrix A, which is 0, 1, 3, 2, negative 5, 6, minus 2 times the second matrix. And by the way, this addition, well, rather, or subtraction, if you will, that's still an addition with a negative term. It's possible because in order to add or subtract two matrices, they have to have the same size or the same dimensions. In this case, 2 by 3 and a 2 by 3. So let's multiply by PEMDAS. We do the multiplications first, and then in the end the addition or subtraction. So 3 times 0, 3 times 1, that's 3 times 0 is 0, 3 times 1 is 3. 3 times 3 is 9, 3 times 2 is 6. 3 times negative 5 is negative 15, and 3 times 6 is 18. And then we subtract. So, well, let me actually keep the negative outside. I'm going to pretend this is a positive. So I'm going to do 2 times 4, which is 8. 2 times negative 2, which is negative 4. 2 times 1, which is 2. 2 times 3, which is 6. 2 times 0, which is 0. 2 times negative 2, which is negative 4. Alright, and then we're ready to perform this difference. So in this case, well, 0 minus 8, that's negative 8. 9 minus 2, that's a 7. Negative 15 minus 0, negative 15. Okay. 3 minus negative 4 minus minus will turn into a plus, so 3 plus 4 equals to 7. 6 minus 6, that equals to 0. And last but not least, 18 minus negative 4, which is 18 plus 4 equals to 22. Final answer. All right. Okay, let's do another multiplication problem. This one is going to be interesting. All right. So let's see. A times C. Let me write down the matrix A, which is 0, 1, 3, 2, negative 5, 6, and the 3 by 3, which is 4, 1, 2, and 6, 2, negative 1, and negative 2, 3, 5. Alright, let's see if the product is possible. Well, in this case, this is a 2 by 3, and this is a 3 by 3. In this case, if you notice these two numbers, that is the number of columns of the first matrix to be multiplied, is the same as the number of rows of the second matrix to be multiplied. So this is okay. And our final answer will have 2 rows and 3 columns, just like the first one. All right. So in this case, okay, let's multiply the first row times the second column. That's the first column of the second matrix. So what I'm going to do is 0 times 4 plus 3 times 6 plus negative 6 times negative 2. In other words, the first product will be 0 times 4, that's a 0, plus 3 times 6, which is 18, and then negative 5 times negative 2, that's a 10. Alright. I'm going to do the same to obtain the second element. So in this case, I'm having 1, 2, 3 elements, 1, 2, 3 elements. So I'm going to multiply the first row of the first matrix by the second column of the second matrix. 0 times 1, which is 0, plus 3 times 2, which is 6, plus negative 5 times 3, which is negative 15. And then I'm going to do the same, the first row times the third column to find this third element. So 0 times 4, which is 0. 3 times, oh wait a minute, 0 times 2, well 0 times 2 is still 0, 3 times a negative 1, that's a negative 3, and negative 5 times 5, that's a negative 25. So we have the first row of the final answer. Now let's find the second row of the final answer, and to do that, we are going to multiply the second row of the first matrix by each column of the second matrix. So I'm going to do 1 times 4, which is 4, 2 times 6, which is 12, 6 times negative 2, which is negative 12. To find this element, we multiply the second row of the first matrix by the second column of the second matrix. 1 times 1, so 1 times 1, which is 1, 2 times 2, which is 4, and 6 times 3, which is 18. Last but not least, we are going to multiply the second row of the first matrix by the third column of the second matrix. In other words, 1 times 2, which equals to 2. 2 times negative 1, which is negative 2. 6 times 5, which equals to 30. So now let's simplify each element. So 0 plus 18 plus 10, that's 28. 0 plus 6 minus 15. Okay, so that's going to be negative 9. And negative 3 minus 25, that's a negative 28. And then, in this case, which is nice, 12 minus 12 go away. We're left with 4. 1 plus 4 is 5. 18 plus 5, that's a 23. And again, 2 minus 2, they go away, and leaving us with a 30. Final answer. All right. Last but not least, 4c minus 6i3. Well, what about that? So let's, the constant 4 times the matrix C, which we have it here. 4, 6 minus 2, 1, 2, 3, 2, negative 1, 5. Minus 6 times I3. What did we say about I3? Well, it's not given in the at the top of the exercise, but we know that I3 means the identity matrix of a square matrix of 3 rows and 3 columns. All right. So what are we going to do? We do the, by PEMDAS, we do the multiplication first, and then we do the subtraction or the addition. Well, in this case, subtraction. So 4 times 4, which equals 16. 4 times 6, which is 24. 4 times negative 2, which is negative 8. 4 times 1, which equals to 4. 4 times 2, which equals to 8. 4 times 3, which equals to 12. And then for the last column, 4 times 2, which equals to 8. 4 times negative 4, which equals to negative 4. 4 times 5, which equals to 20. Minus, okay, let me keep the minus. I'm going to pretend it's not there. Well, 6 times 1, which equals to 6. But in this case, 6 times 0 and 0, just bring down the zeros and keep the 6 along the main diagonal. All right, that's, if you will, like a shortcut to multiply the identity matrix by a constant term. All right, so another trick. For the final answer here, notice a bunch of elements. To a bunch of elements on the first matrix, we are going to subtract 0. That is all the elements that are not in the main diagonal. So what I'm going to do is simply subtract 6 to the elements in the main diagonal. 16 minus 6, that's 10. 8 minus 6, that's 2. 20 minus 6, that's 14. And then the remaining elements, the rest of the elements remain the same. 24, negative 8, 4, 12, 8, negative 4. Final answer. And this is a good place to quit. I'll see you in the next video.